To find the conjugate complex of the complex number 1 by 1 plus I. Now in order to find the conjugate complex, first we have to convert this into A plus IB form. In order to convert this into A plus IB form, we have to rationalize. So we'll rationalize the denominator. Its rationalizing factor is 1 minus I. So we'll multiply and divide the given complex number by 1 minus I. So 1 into 1 minus I is 1 minus I by 1 plus. We know that I square is minus 1. So this will become plus 1. So the given complex number is nothing but 1 by 2 times of 1 minus I. Now the conjugate complex of this number is nothing but 1 by 2 times of 1 plus I, which can be written as 1 by 2 times of 1 plus I. Again, if I further rationalize this by 1 minus I into 1 minus I, then this will be half of 1 plus 1 by 1 minus I, which can be written as half into 2 by 1 minus I. So the required answer is 1 by 1 minus I, which is nothing but option A. It is given that A and B are mutually exclusive events, and we have to find probability of A plus B, that is nothing but probability of A union B. Now we know that probability of A plus B is nothing but P of A plus P of B minus P of A intersection B. Now as A and B are mutually exclusive, this intersection will be always 0. So the required answer is P of A plus P of B, which is nothing but option B.
This transform of L of S is, here we know sin AT is equals to A by C cos AT. The Laplace transform is S by S square plus A square. So T cos AT is nothing but minus D by ds S by S square plus A square. That is S square plus A square whole square, S square A square minus S into 2S, that is 2S square. So minus S square plus A square, S square plus A square whole square. So if we take minus outside, S square minus A square by S square plus A square whole square. That is option C is correct. Of expectation of x is, suppose here assume expectation of x is k, which is a constant. It is going to be a mean value. So expectation of a constant is nothing but a constant, because it is the expectation is nothing but a linear variable. So k is nothing but expectation of x. That is option B is correct.
It is given that from a pack of cards, 2 cards are drawn at random. Now we have to find the probability that both the cards will be king if the first card is not replaced. Now we know that there will be 4 kings out of 52 cards. So in the first pick, what is the probability out of total 52? We are taking 1 card, so 52C1. And what is the probability that it is a king? There are 1 chance out of 4, 4C1. So which is nothing but 4 by 52. This is in the first pick. But in the second pick, what is he saying? The card is not replaced. If the card is not replaced, there will be only 51 cards here and 3 kings, because already we have taken 1 king. So what is the probability? The next probability will be 3 by 51, which is nothing but 1 by 221. That is option D.
Rated voltage per phase reduced to 1/2. That means V applied, or you can say V2 is equal to 1 by 2 times of V1. The starting torque of the 3-phase squirrel cage induction motor becomes, okay, torque is directly proportional to applied voltage V square. So what is T2 by T1? T2 by T1 is equal to V2 by V1 whole square. So this is equal to 1 by 4. What do you mean by that? Torque 2 is equal to 1 by 4 times of torque 1. Okay, so option B is the correct, since it will be reduced by 1 by 4 times of the initial value T1. Option B is the correct answer. Flux density in the air gap of a synchronous generator is lowest during. Okay, now induced EMF E is directly proportional to air gap flux density, that is Bmax. Let us take it as, okay. Now this Bmax is directly proportional to V by F. Now in open circuit test we have rated voltage, so Bmax is high in open circuit case. Similarly at full load also we have rated terminal voltage Vt, which is having more than that of short circuit voltage Vf. Now what is meant by short circuit? Short circuit we have current value very high whereas voltage value is very less. So since Bmax is directly proportional to the applied voltage V, Bmax will be low in case of short circuit. So option B is the correct answer.
Across the terminals A and B is, here voltage across the parallel elements is going to be equal, that is VAB is nothing but a 5 volts here, because the 5 volts is across the current sources also. So option B is correct. The below given circuits, if V1 is equals to V2, both circuits are possible, hence option A is correct, because in circuit B this is V1 and this is V2. Whatever may be the V2, this circuit is going to be possible, but in case of circuit A, if V1 and V2 are not equal, circuit A is not going to be possible. But the case given in the question is V1 is equals to V2, hence both circuits are possible. That is option A is correct.
Ohm's law in point form of field theory can be expressed as, okay, V is equal to IR. This is in circuit theory, but what we have to find here, Ohm's law in point form. We know that V is equal to IR. Okay, so V is equal to I into, what is resistance here? Rho L by A, or we can define this one as I into L by sigma times of A, where rho is called resistivity and sigma is called conductivity. Okay, so 1 by rho is equal to conductivity. Inverse of resistivity is equal to conductivity. Now from this we can write this one as V by L is equal to I by A into 1 by sigma. So what is V by L? V by L is given as electric field, okay, voltage for some distance. Okay, now I by A is current per area, which is equal to current density J into 1 by sigma. Now from this what we'll get? J is equal to sigma E. So option C is Ohm's law in point form. For 50 kilometer length of the line is, capacitor of 50 kilometer length of the line is 150 microfarad. What is the capacitance for 100 kilometer line? Capacitance of the transmission line is always directly proportional to line length L. So C 100 kilometers by C 50 kilometers is equal to L2 by L1, which is equal to 100 by 50. So what is the capacitance for 100 kilometers line? It is 2 times of capacitance of 50 kilometers. So this is 150 microfarad, which is equal to 300 microfarad is the answer, option B. Parallel feeders feed from one end. The relays required are, okay, he has given for the protection of these parallel feeders. Okay, then let's say this is a load end, or you can say it as substation end, and this one is feed from one end. This is, you can say it as source end. For the protection of parallel feeders from one end, the relays required are, okay, for this type of feeders always we will require overcurrent relays. Generally we will use overcurrent relays. There are two types. One is non-directional, another one is directional. Always non-directional is placed at source end in order to protect this generator, whereas directional relays is placed at load end. So option A is the correct answer. Systems operated with power angle around. Okay, in power system generally there are two types of powers are important to know the power angle, that is P is equal to power transferred in transmission line. Generally it is given as Vt into Vr by X into sine delta. This is what power. What is synchronizing power coefficient? Dp by d delta is equal to Vt into Vr by X into cos delta. Okay, generally in power systems we will use synchronous generator. Okay, when synchronous generator means it should always run at constant speed, that is synchronous speed ns. Okay, what happens if speed is increased beyond synchronous speed? Okay, the synchronous generator should not fall out of step from the transmission lines. So what we have to do is we have to maintain power angle delta such that when sine delta and cos delta will be equal, sine delta and cos delta will be equal around 30 to 45 degrees. Generally exactly at 45 degrees they both are equal, but power systems will generally maintain at 30 to 45 degrees to provide a good sufficient synchronous coefficient as well as synchronous power. Okay, so option B is the correct answer.